Thank you. Hi, I'm Arran Schlossberg. I'm the TL of the EVM team. So that basically means if there's something to do with Ethereum compatibility, I'm expected to have an opinion. And so these are some of my opinions on how we do that. I'm going to be talking about libevm. That's our new fork of Geth. You're probably thinking that maintaining a Git fork sounds incredibly boring, and you'd be right. But the talk is not. It's got everything. It's got everything from race cars to a villain with a redemption arc. You got to think like Fast and the Furious meets Zen and the art of Git maintenance. That's what I'm going to present now. So hands up, who has forked a Git repo? Everyone. Okay, hands up, who enjoys resolving merge conflicts in a Git repo? There's always one. I've got a job for you soon. Has anyone tried to maintain a fork of Geth? Yeah, okay. So it's hard. It's a pain. So Geth is the official Go Ethereum client. It's being actively developed. So when we create a fork, we're not just taking our own copy and then literally forking off. We're trying to bring in their features, make our changes, have everything work nicely together. That's notoriously brittle. It's a difficult thing to do. And what happens over time is you get this ever-growing complexity. You do something, they do something, you mix it together. Anytime something breaks, you go, oh, who was that? Was that me? Was that them? Where does this problem come from? And over time, what happens is you get this reduction in trust in your own system. It becomes ever more complex and hard to understand. And so how do we tame that? The best analogy I can think of is like doing a pit stop while a car's still moving, but every single lap, the dimensions of the tires change. So what do we do to fix that? Okay, so I said it would be an interesting talk, but it's very hard to weave narrative tension into a talk on software practices, but just embrace the melodrama and we'll get the best out of this topic. So every story needs a villain, and ours is a wall of merge conflicts. We had a volunteer from earlier who said that he'll resolve all of these conflicts. This is a little bit exaggerated, but this is somewhat reflective of what we used to have to face when trying to merge Geth back into our changes. I've exaggerated it for effect, but you can see, if anyone's familiar with the Geth code base, this is just everything over time. So how do we actually attempt this? How do we tackle this villain head on? So I said there'd be high-speed action. Why do race cars have brakes? Anyone? Yeah, it's not to slow down, it's to go faster. So you have brakes so that when you get to, so it's to allow you to go fast, so when you need to change and do something else, you can slow down. And that is kind of the mentality of libevm. And that's why this is the beginning of today's talk on how we make the C chain fast. We start with like, how do we set up the safe guardrails, and how do we then build on top of that in a way that makes it maintainable and safe? So how do we go about that? Like, it feels like an insurmountable task when you're just faced with a wall of conflicts like that. And the first thing is a little bit counterintuitive. Like, we are depending on Geth for their features, but really the core insight in how to do something like this is they're depending on us. Anytime that we bring in some of their code, it's a tautology. They made a change, they expect their code to still work. So we can't go and change everything. We have to be really fastidious about making sure that everything is backwards compatible. And that's quite difficult. It means that when we have a change, we bring theirs in, it doesn't break it. So basic things we do, we make sure that with every single commit that goes into this repo, we measure how invasive it is. We have a report that goes into every PR, says, you've broken this many things. And then it's like, is that okay? Is that not? But it needs to be kept down. By default, the whole of our EVM compatibility is backwards compatible. So when there is a test from upstream, we don't break their tests. We know that it's still working because of this default behavior. And the syntax is compatible everywhere too. So now we have these interesting design constraints of you're not allowed to change the default behavior, you're not allowed to change the syntax so that it doesn't work everywhere, but now you also have to support the Avalanche C chain and the 5 years of history, 6 years of history that have gone into it. So how do we go about that? But this is the ethos that it happens, and I'm going to get into how we actually achieve it. So it's called libevm, it's as in an EVM library, and the idea is like when you import a library, you don't patch it. You use it as a library. So we externally register everything. You never actually touch the EVM code base. And this means that anyone here who wants to have an EVM compatible chain that they can completely customize can do the same thing. You can bring in hooks. It's what you expect a hook to be. It changes the behavior. Payloads are just arbitrary data that get carried along with original types within Geth. You can say, if type A is somewhere, I want type B to be like a sidecar that gets carried along with it. And what we do within this library is we only define what you can change, not how you can change it. That has to happen externally. And that maintains a really safe boundary for maintaining the repo. And because of this, we're agnostic. We don't care what the final use case is. Like, yes, you could run an Ethereum node, you can run a C-chain node. If anyone's watching the recording and you're from another EVM-compatible chain, file an issue if you want to talk about bringing your chain across as well. That would be a dream North Star for me, that you can run any EVM-compatible chain like that. And by having this clear delineation, it makes merge conflicts not disappear, but go away as much as possible. From the outside, if you're a user of this, it's fully type safe. You don't have to accept a Go interface. How many Go developers are there here? How many non-Go developers, sorry? Okay, so to quickly explain, in Go, an interface it's implicit. It says, this is the behavior that exists. It could be any concrete type that implements it underneath. And so a really annoying thing that you have is that you then have to cast it back to your concrete type, which is unsafe. And we don't want users to have to go through that. So we maintain internal invariance for type safety without littering the entire code base with type parameters everywhere. So that's just a nice, useful thing for people. And the way that we do that is we don't patch, we plumb things everywhere. So there are certain types that just go everywhere in the Geth code base. There are chain configs that define how the chain works. There are rules. And because of the nature of what they do, they're just naturally everywhere. And we get coverage of most of the code base without actually having any direct footprint on the changes that we make there. So we're in dark mode. That means that it's now the interesting thing. There's a bit of code. And here's an example of how this works. So anytime you see an import that's libevm, you can think of it as importing the Geth equivalent package. And this is the interesting thing. We have our 2 extra payload types that we're defining here, a config extras and a rules extras. And by calling this register extras with these generic parameters, it says from now on, any time that you have a chain config, which is an internal type in Geth, or you have a rules, they will always have extra payloads that get carried with them. Which means if you want to change when do you activate an EIP or when do you activate an ACP or anything, you just have that carried along with you. And this happens throughout the code base. It gives you back a payloads, which we set here in the global variable, and that allows you to have type-safe access to extract these payloads at any time. And then this is an example down below. It's just to show the internals of how things might work. This is how you would, for example, override a precompile. Really simple. You'll notice the package is just called Summit. We haven't changed libevm at all, but suddenly we've introduced custom precompiles just through 24 lines of code, plus the precompiles. But it's a really simple, external, minimal impact, easy to use change. We absolutely obsess over backwards compatibility in this library, both semantic, as in what does it mean, what is the behavior, and syntactic. Syntactic is like, if I call a function, I do not want that syntax to change. But now I need to bring in arguments, but I have to have all the original call sites remain unchanged. Because otherwise, every time I bring in an import, I have to change every single call site throughout the entire code base and just do this enormous refactor. So we want there to be seamless syntax. And the way that we achieve this, for anyone in Go, it's pretty simple to see. It's just variadic arguments. So this method over here is an original geth method, but by using this syntax, these variadic arguments, and then plumbing them through, that's the only thing that we change, and that means that you as a user can inject changes to the behavior, but if you call this from an internal geth test or other place where you haven't plumbed these arguments, it will just work still, and it'll default back to the default behavior. And we actually haven't changed a single upstream test. They remain 100% bit by bit exactly the same. And that says that we're doing things right. If we change it, we're no longer a fork, we start becoming more of a rewrite. And then when things diverge, we get that complexity again. And that's what we're trying to what we're trying to tame. So something that we had our villain, we had to conquer the villain. That is the original set of merge conflicts. And for an equivalent update, this is the new set. It's not perfect. It's never going to be perfect. One thing that I'd really like to say is the old way, it wasn't a bad way. It just became unsustainable over time. Over many years, things build up, and you get complexity that you hadn't planned on complexity. All this work to get to a stage like this takes a lot of upfront investment that at the beginning of Avalanche would have been a terrible resource allocation. So now is the right time for us to be doing something like this because we're doing this push to moving fast. We want to go extra fast, so we're first upgrading the brakes. Well, we've upgraded the brakes now. And you'll notice I didn't talk about features. I didn't tell you all the things it can support. It supports everything that C-Chain has already supported. But I've told you about how we make building those features safer, faster, and more enjoyable for developers. If you're making a precompile, you don't want to have to worry about all the technical debt. You just want to make your precompile. You want to change your chain how you want to change it. And so that's the goal here. And now we have these minimally invasive diffs that we can apply every time we want to do an upgrade. We want to bring new geth code in. And they're at the point that they're possibly automatable. We haven't automated them, but they've been structured in a way that everyone can just be applied as a Go syntax change. And so now our merge conflicts are also objectively resolvable. There's no opinion of how, was the intent this or was the intent that? It's well known, well understood, and we can just apply it if we have a conflict. So we've shrunk the conflicts, but we also know how to resolve them. So I said at the beginning that Git fork maintenance was boring, and that was true. That's by design. There's already enough complexity in doing this. We do not want to add any more unexpected turns and twists to the road. We want it to be boring. That is the intent and the purpose of this project. It's the brakes that allow us to go faster. And my next talk, I'll be speaking about what we'll be doing to make things go faster. Any questions?
Yeah, what is the current state of the project like? Can I try to swap subnet EVM for libevm right now?
Yeah, so the question was, did everyone hear that? Can you swap out subnet EVM using libevm? So yes, both C-Chain and subnet EVM. Subnet EVM is what powers our EVM L1s. They are both running on libevm. They use the hooks themselves, but you can then plug in on top of that. So all of these things exist there. They currently cover precompiles, so everything about execution. So how do we change execution? How do we change block headers and block formats things like that as well, and some state changes as well. So that's everything that it covers.
Any other questions for Arran? Anyone? Awesome. Can I get a round of applause for Arran, please?